All right, Kipsters, this is the third video. And this video is going to be going over questions 16 through 23. So if you're sitting in for the whole ride, we're going to start with 16 and go all the way to 23. Make sure you have your mock assessment open to those questions now. This is what the front of the mock assessment looks like. All right, 16 through 23. Here we go. Number 16. Which of the following equations is true? All right, we can't block any of these. We got to check A, B, C, and D and see if they're true. And I'm seeing this parentheses thing. It's reminding me of something we did a long time ago called the distributive property, where we drew these little arrows to see if they're equal. But we'll talk about that in a second. Let's just set up our page a little bit. You can see what I did over here. I just want to check to see if each one of these is true. We're going to go through each one at a time. That's the best way to do problems like these, okay? So let's take a look at letter A. Now, if you remember the distributive property, you're basically distributing the 4 to the 7 and to the other 7. So what that means, I'll show you one quick example. This means 4 times 7, which is what? Call it out, please. 28. Then you bring down the plus sign, like that. And then you do 4 times the other 7. What's 4 times 7 again? 28 is right. So is 28 plus 7 equal to 28 plus 28? No way. Look, you can add them both up if you want, but you can already tell 28 plus 7, 28 plus 28, they're not equal. So I'm crossing it out over here. That means that equation is not true. All right, let's try letter B. I start with my parentheses over there. I'm going to do 6 times 6, which is what, y'all? Call it out. Bring down my plus sign. 6 times 1. That's 6. 36 plus 6. 36 plus 6. I'm liking that one, but you know I'm going to go through the rest and just double check. All right. 13 times 1 gives you 13 is right. Bring down the plus sign. 13 times 3. Go ahead and call it out if you know it. That actually makes 39. 13 plus 36. 13 plus 39. Not equal. Okay. Last one on the bottom. 20 times 4 is 80 is right. Plus 20 times 3 is 60 is right. 80 plus 60, 80 plus 70, they're not equal. And there you go. Okay, there are other ways to solve this. Some people did 7 plus 7, which is 14, times 4 makes 56. But I did want you guys to see this as well, because this means the same as 4 times 7 plus 4 times 7. Okay, also known as the distributive property. That was question number 16. Let's move on. Question number 17. Jaquan paid for the items listed below with a $20 bill. 1 jar of peanut butter that cost $2.39, 2 loaves of bread that cost $2.75 per loaf. What was the total amount of money Jaquan got back after he paid for the items? I don't need my answer choices. I'm actually going to solve this just using my brain. So, key information. Had a $20 bill. Bought a jar of peanut butter. Bought 2 loaves of bread that cost $2.75 per loaf. We want to know how much money he got back. All right, first, it'd be good to know how much money he actually spent. So, let's start with the peanut butter. That's $2.39. He only bought one of those, and this is the one that tripped up a lot of people. He bought 2 loaves of bread at $2.75 each. So he bought the peanut butter and 2 loaves of bread. And when you add all that up, he actually spent, and I know you all can add, so I'm just going to show you, $7.89. Now, is that our answer? Call it out. Why is that not our answer? Go ahead and tell the screen. Talk to the screen. Why is that not the answer? Yeah, if you said something about they want to know how much money he got back after he paid for it, you'd be right. So what's the last thing that we need to do to solve this problem? Go ahead and call it out. Yeah, we're taking the $20, and we're subtracting it from how much he spent. And you can see I'm already doing the scratch and making it smaller, and pull one on my side. You got to be careful with that, because I'm pretty sure one of those answer choices is going to test how well you can subtract. But if you do the subtraction correctly, you'll get $12.11. Let's pull that away. And there it is over there, $12.11. Okay, nothing more than a quick multi-step addition and subtraction problem. Big thing is you got to read carefully. It was 2 loaves of bread. All right, moving on to number 18. Here we go. A recipe for sugar cookies calls for 3/4 cup of sugar for 1 batch. Daniela buys a bag of sugar to make cookies. If the bag of sugar contains 7.5 cups of sugar, how many batches of cookies can she make? All right, this sounds a little confusing, but I'm ignoring my answer choices and just focusing on the key information. 3 cups of sugar for a batch of cookies, okay? And then she has 7.5 cups of sugar, or she bought a bag that was 7.5 cups of sugar. Okay, I know this is a little tricky because it doesn't have those words every, and it doesn't have the word each or per. But this 3/4 cups of sugar for 1 batch is very much like a ratio. Or you could have said for every 1 batch. So we are making a ratio table here. Okay, and what we'll have is cups of sugar. That's pretty obvious. Then the other one would be batch for 1 batch. And right here is the first thing I'm going to write in my column because it says 3/4 cups of sugar for 1 batch. 3/4 cups of sugar for 1 batch. There you go. The 7.5 is cups of sugar. So should it go here or should it go here? Point to the place it should go. Are you pointing up there? Then you'd be right. Okay? So now, next step, always the same thing. Highlight the column that you know and draw an arrow from the column that you know to the other piece of information in the other column that you know. And now you ask yourself, how many 3/4 are in 7.5? And you're like, yo, I don't know. Sorry about that. That keeps happening. So look, how many 3/4 are in 7.5? That is the same exact thing as saying 7.5 divided by 3/4. Okay? It's really important that you understand how many 3/4 are in 7.5. That's what this expression means. So now we know how to solve this. We got to use our keep, switch, flip strategy. There are other ones to use, but we like using that one the most. So now you keep 7.5. There it is. There's 7.5. You want to keep that, but you actually want to make it into an improper fraction. So we're going to do the crank, as we call it, a kip. So can you crank 7.5? I'll give you a second. Call out in your head what happens when you crank 7.5. What should you get? Go ahead. 15/2 is right. So we keep. Now we switch, and then we flip. Okay? Now we're going to shoot across. 15 times 4, not sure if you can do that in your head, but it does equal 60. 2 times 3, you better be able to do in your head. That equals what? Call it out. 6. So it's 60/6. And then you could do get off my back to create, go from big-headed to a mixed or whole number. 60 divided by 6. The 60 goes in the house. That goes in perfectly 10 times. So believe it or not, if you take 3/4 times 10, you will get 7.5. That's what all this told us. Okay, whatever you do to the top, you do to the bottom is right. So 1 times 10 should give you 10. Let's pull it away and see if it's there. There it is right there. Okay. So now you know what I'm going to do with ratios. I'm going to show you another way. Okay. You could always highlight the column that you know, but you can also highlight the row that you know. Check it out right there. And then you can see how to get from the row that you know to the other piece of information that you know in the other row. So getting from 3/4 to 1, well, that's just divide by 3/4 because any number divided by itself is going to give you 1. So if you do 7.5 divided by 3/4, hey, that's just what we did right there. And that is also going to give you 10. Okay, so no matter which way you do your ratio table, it's going to get you that number. Just remember to keep, switch, flip when you're dividing mixed numbers or fractions. Okay, that was number 18. Let's move on. Number 19. Whoa, it's a lot of information. Anita and Jerry are reading the same book. The graphs below show the number of pages Anita and Jerry read each day for 5 days. All right, I see some graphs here. Total number of pages read and how many days. You know, these people are reading a lot. That's good. All right, let's check the bottom. It says, what is the relationship between the number of pages Jerry read each day and the number of pages Anita read each day? I see Jerry read twice the number of pages Anita read each day. Jerry read the same number of pages as Anita read each day. Jerry read 3 times the number of pages Anita read each day. Jerry read half the number of pages Anita read each day. We can't block off these multiple choice answers because we need to figure out which one of these is actually true. And here's what we're going to do. I'm going to look at a point on the graph, and you know the way I am. I'm going to pick the one that's the smallest one that's known, and you can see it right on Anita's graph. I went right there, and that says for Anita in one day, she read how many pages? 60 is right. So I'm going to put that over there. Anita, one day, 60 pages. Now, if we're going to try and compare Jerry and Anita, we're going to have to go to this one day one for Jerry. How much did Jerry read in one day? Well, there's the information right there. Go ahead, call it out. How much did he read in one day? Yeah, he read 30 pages. So now, which of these answer choices, if we know this is true, and it is, we just read it off the graph, which of these is true? A, B, C, or D? Jerry read twice the number of pages as Anita? No, he didn't. He read less than she did. Jerry read the same number? No, he didn't. He read less than she did. Jerry read 3 times the number of pages? No, he didn't. He read less than she did. Jerry read half the number of pages? That's true. Jerry read half as much as Anita. Okay? So a different kind of problem there, but still using the same strategies that we've used before. Okay? That was number 19. Let's move on to number 20. A restaurant orders 3 bottles of tomato sauce for every 4 boxes of pasta. The restaurant ordered 12 more boxes of pasta than bottles of tomato sauce. How many bottles of tomato sauce did the restaurant order? All right, I'm not looking at these answer choices. I can solve this without it, but this one, we got to read real carefully here. There's some key information. 3 bottles of tomato sauce for every 4 boxes of pasta. I see that phrase. I'm thinking ratio table already. There's more. The restaurant ordered 12 more boxes of pasta than bottles of tomato, and then the answer they want is how many bottles of tomato sauce, which is going to be important too. Okay? I saw 3 bottles of tomato sauce for every 4 boxes of pasta. Tomato sauce, pasta, you could have put bottles there and boxes there. So it's all good. Okay? And I see 3 bottles of tomato sauce for every 4 boxes of pasta. So I put my 3 there and my 4 there. I'm looking good. I'm seeing that 12. I'm thinking, should it go here? Should it go here? The restaurant ordered 12 more boxes of pasta than bottles of tomato sauce. Here we go, y'all. You gotta really think. Did it tell you that the restaurant ordered 12 boxes of 12 bottles of tomato sauce? Did it say that? No, it didn't. Did it tell you 12 boxes of pasta? No, it didn't. It said 12 more boxes of pasta. So you can't put 12 here and you can't put 12 there. What it did tell you was the difference between the number of boxes of pasta and the bottles of tomato sauce. So you actually have to make a 3rd row to your ratio table because that's the information that it told you. It told you how much more pasta than tomato sauce. Now, this is where it gets tricky. You don't put 12 in here, okay? If there were 4 boxes of pasta and 3 bottles of tomato sauce, just for this ratio, how much more pasta was there than tomato sauce? Go ahead, call it out. What's the difference between the pasta and tomato sauce? It's just 1. But when the restaurant made their order, the 12 goes down there. Okay, that is super tricky. We're going to talk about another strategy to do this problem as well, but you can do it with a ratio table. You just have to read really, really carefully. Okay? And now once you got that, we just have to figure out how to get from 1 to 12, and that's a joke. That's times 12. Okay? Now the question asks for how many bottles of tomato sauce. So you can multiply both of these times 12, but the only one we really care about is the tomato sauce. 3 times 12 gives you what, y'all? Call it out. 36 is right. Doesn't matter. This is 48, but you don't need it. The answer was 36. Okay, this is a really tricky ratio table problem, and it's because you have to read carefully about 12 more boxes of pasta. I wanted to show you something you guys are familiar with as well. This is using a bar model, and it showed 3 bars. Ignore the 12s for a second, but 3 bottles of tomato sauce. That's 3 boxes for every 1, 2, 3, 4 boxes of pasta. And then here's the key point right there. The 12 is the difference between the pasta and the tomato sauce, which means all of these are 12, which means the tomato sauce equaled 36. Okay, so that was super tricky, but you got to expect to see these every once in a while. Okay, that was number 20. The answer was 36. Moving on to 21. Jenna and Diana have sold 3 quarts of lemonade so far today. How many gallons have they sold? I don't need the answer choices. I need my brain. Here we go. Key information. 3 quarts of lemonade. And the question says, how many gallons have they sold? Oh man, I only see one number in here. And I'm feeling like I need a ratio table. But I only have one number. But then I remember quarts, gallons. I know I got to put the 3 in there somewhere. But raise your hand, or since I can't see you, just call out, where do you think we're going to get this other information from? Go ahead and call it out, see if you remember. If you said the reference table that you're given on the test, you'd be right. Look down here. This is part of the reference table that you're given. Can you sneak a peek for a second? Can you point to the conversion rate that you're going to need to solve this problem? We're looking for something that'll help you go with quarts and gallons. Go ahead to point to it if you see it. Go ahead, point. Yep, there it is right there. 1 gallon equals 4 quarts. So we're going to take that rate and we're going to put it right into the ratio table. So it says 1 gallon, 4 quarts. So I'm going to put my 4 quarts and my 1 gallon right there. Perfect. Use your reference table to fill in that first column. And now 3 quarts, we'll take a guess where we're putting that 3, right where quarts is. Okay, now we just need to solve for what goes there. Same steps as always. Highlight the column that you know, and then draw an arrow from the column that you know to the piece of information that you know in the other column. But now look at that. Going from 4 to 3, how many 4s fit into 3? Well, that's the same old division problem as always. That is 3 divided by 4. And you can already tell, and that should make sense, the answer is going to be less than 1. Okay? Because 4 doesn't go into 3 more than 1 time. It goes in less than 1 time. In fact, this question is more simple than you think. 3 divided by 4, which is right as a fraction, is 3/4. Okay? You got to remember that because the division sign means, the fraction bar is the same thing as the division sign. So 3 divided by 4, 3 divided by 4 is the same as 3 divided by 4. So that literally means if you take 4 times 3/4, you will get 3. And I swear, if you do it on the side, you could pause the tape now and do it on the side. 4 times 3/4 gives you 3. Whatever you do to the top, you do to the bottom is right. Times 3/4 down there. 1 times 3/4. Well, that's easy. That's just 3/4. Pull away my answer choices. 3/4 is the answer. But you know me by now. If I show you one ratio table, I'm going to show you another way to do it. Look down here. You don't always have to highlight the column that you know. You could highlight the row that you know. Okay, and then draw your arrow from the row that you know to the information in the row that you don't know. So going from 4 to 1, that's pretty simple, right? 4 to 1 is divide by 4. Whatever you do to the left, you do to the right. 3 divided by 4, take a look. 3 divided by 4 gives you 3/4 either way. So how many gallons did they sell? 3/4. Now, if you were super smart and you were thinking, if you already knew there were 4 quarts in a gallon and they only sold 3 quarts, there was only one answer that was less than a whole, and that was that one, okay? But that's the exact way to solve it. Cool. Question number 22, almost done. Here it is. The expression 6 to the 3rd power times 4 to the 2nd power is equivalent to which of the following numerical expressions? I don't want to block this because I need those to figure out which one is equal. Okay? So there it is, 6 to the 3rd power times 4 to the 2nd power. Let's just break this up. because I'm seeing all sorts of wacky answers down here. Let's start with 6 to the third power. 6 to the third power means 6 times 6 times 6. So let's just write that down. Okay? And now, 4 to the second power, what's that mean? Call it out, please. Yeah, that means 4 times 4. All right, I'm going to pull down my multiplication sign. Let's see if this is one of the answers, because I know this is true. 6 to the third times 4 to the second is the same as this. I'm looking at my answer choices. That looks weird, letter B, but I don't think that's true. All right, I don't see it yet. So let me simplify this further. Let's take a look at 6 times 6 times 6. Let's just do the order of operations. What is just 6 times 6? Call it out, please. 36 is right. I'm going to pull down my times 6. Now let's do 36 times 6. That's not something I'm going to try and do in my head. I'm going to write that on the side. Now, go ahead and solve that. I'll give you about 10 seconds. 36 times 6. Did you get 216? If you did, you were right. All right, cool. 216. Oh, I see one of those things right in the letter D. Maybe we're close. All right, so we solved 6 to the third power. That's 216. 4 times 4. Call it out, y'all. That's 16. Huh. So 216 times 16. I see that answer right there. Okay? Now, and this is why it's important to sometimes you do need your answer choices, because I don't want you doing 216 times 16 when the answer was right there, and I saw a lot of people doing that on the test. Sometimes you need your answer choices to help you throughout the question, because it'll save you some time and some work. Okay, so number 22, the answer was letter D. I swear if I ever see anyone do 6 to the third power being 18, I'm going to go crazy. You know 6 to the third power means 6 times 6 times 6. Okay, cool. Last one we're doing for this video, number 23. Here we go. Whoa! There are 4 story problems found below. Which of the stories can be solved by using 1/2 divided by 1/8? I know you guys don't like these problems, but I actually love them, because what I do is I take, before I even read anything, I take that division problem and I just solve it. And that's an easy division problem to solve. Look over here now. Look at where I'm circling. 1/2 divided by 1/8. In fact, I bet most of you can do the keep switch flip in your head. Go ahead, do it in your head. So we keep the 1/2, change the division to a multiplication is right. 1/8, the reciprocal of that is 8/1. Shoot, that's 8/2. And that reduces to 4/1, or 4 wholes. Okay, so basically, we're looking to see which story problem, there's 4 of them here, can give you an answer of 4. So let's read through each one and see which answer would get the answer of 4 would make sense. So here we go. Adriana received a necklace that was 1/8 of a yard long. She accidentally dropped the necklace and it snapped in half. What was the length of each piece of the necklace after she dropped it? So we are trying to figure out, would 4, in this case yards, because the unit was yards, would 4 yards be an answer that makes sense? So I'm going to look back. Wait a second, this doesn't make any sense at all. The necklace she got was 1/8 of a yard. Then she dropped it and it cut in half. 1/8 of a yard is less than a yard. How could the length of each necklace be 4 yards? Each piece of the necklace be 4 yards. That's crazy. That's more yards than she started off with to begin with. That answer is definitely wrong. Okay? Let's move to letter B. A scientist created half of a cup of a green substance. She then found small vials that could hold 1/8 of a cup of liquid and started pouring the green substance into the vials. How many vials could she fill? How many vials could she fill? Could she fill 4 vials? See, I'm thinking maybe because she had half a cup and then she started pouring it into things that were 1/8 of a cup. And I think that could work. I'm not 100% sure, but let me look at the other ones. And if the other ones are dead wrong, I think I'm going to go with letter B. So let me skip and go to letter C. Let's read letter C. Ashley has 1/8 pounds of cookies. She wants to share the cookies equally between herself and her friend. How many pounds of cookies will each of them eat? Will they each eat 4 pounds of cookies? Because we're looking for an answer that says 4. No, man, that's crazy. Are you kidding me? She only started off with this much. She started off with less than a pound. That's just like letter A. This one's crazy. 4 pounds of cookies, you'll have diarrhea for a month. No, that's wrong. Now let's go to letter D. Jared was working on his homework for half an hour. He finished in 1/8 of an hour later. How many hours did it take Jared to finish his homework? Did it take him 4 hours? No, that's also crazy. Look, half an hour and then 1/8 of an hour. That half an hour plus an eighth of an hour, that's still not even an hour, let alone 4 hours. No way. The answer is 100% letter B. And it would be true, because if you think 4 vials with 1/8 of a cup in each vial, that would be 1/8 plus 1/8 plus 1/8 plus 1/8. That's 4/8, which is the same as a half. Okay, don't get tripped up, man. Solve the problem and then see which answer makes sense. Okay? That was question number 23. That's the last one we're going over for now. We got one more video to go. Thank you for your grit and your love of learning. I'll talk to you soon.